Hey Dinosaurs, and welcome back to this week's episode. Today we're going to be learning how to get our dinosaur to do some simple mathematics. And as an added bonus, you're going to also learn how to get him to write text to the screen so you can see what's going on inside his brain. So I wonder if you've ever heard about the word gigahertz when reading about your new laptop or your new iPhone and wondered what gigahertz actually means. Well, let's break the word up into its two parts. The first part, giga, means billions. Just like kilo in kilograms or kilometers means 1,000, giga means not 1,000 but a billion. So instead of saying there are roughly 8 billion people in the world, you might say something like there are 8 giga people in the world. So next time you hear the word giga, just think 1 billion, and that's 1,000 million, or 1,000,000,000, and that's a lot. The second word in the word gigahertz is just hertz. This is a word you'll one day learn in your physics class to mean the number of times something happens every second. So if you clap your hand twice a second, you're clapping at 2 hertz, whereas if you clap your hand 5 times a second, you're clapping at 5 hertz. So when you read that your computer runs at 5 gigahertz, what that roughly means is your computer is able to do calculations 5 billion times every second. Can you even imagine that? Think how long it takes you to add 2 numbers together or multiply 2 numbers in your head. Well, a modern computer, or even your iPhone, can multiply billions of numbers every second. It's just totally crazy, and we're going to have to start taking advantage of that. But before we do that, I want to teach you how to get our dinosaur to write text onto the screen so you can see what's going on in his head. This new command is called write, and it accepts 2 parameters. The first one is what you want it to write to the screen, and the second one is how big you want the writing to be. Let's have a look how it works. So there we have it, the first time our dinosaur's actually spoken to us. And you'll see if I change that second number, you'll see that the writing can get bigger and smaller. I'm going to leave it at size 1. Now our dinosaur is going to keep getting in the way of our writing today because he literally drops the writing just underneath him. So what we're going to do is we're going to make sure that we've picked up our pen, and every time we've written to the screen, we're going to move forward 20 centimeters. So that our dinosaur moves away from what he's just dropped on the screen. So in this first example, we passed a string parameter to the write function. Remember, strings are simply names of things like colors or sentences you might want to write to the screen. Strings are whatever you put inside double quotes. So it's not only strings we can write to the screen, we can also write numbers to the screen. So if I put the number 42 here, run the program, you can see our dinosaur has now dropped the number 42 and moved forward. Now remember our friend the constant. If you look at our program, we already have 2 magic numbers lurking in there. One is the size of the font we're using, or the size of the text we're using, and the other is how many centimeters we want to move forward each time we have written something to the screen. Let's tidy those up and use constants instead. So here we go. And remember, I can now replace these magic numbers with my constant names. I run the program. Nothing's changed because we just literally replaced the magic numbers with the constant names, but that writing's looking a bit small, so I'm going to make it 1.5 big. And I'm only going to move forward 15 because we're going to run out of space. So you see how cool constants are? You just have to update them in one place, and all those places we were writing to the screen and moving forward are now automatically updated. So in addition to passing numbers and strings to the write command, we can also pass constants to it. So let's imagine we have a constant 1, 2, 3, 4. Well, we can now be passing that constant as the first parameter to the write command, and if we move forward, we'll see our turtle reveals 1, 2, 3, 4. So there's our constant 1, 2, 3, 4. We've passed it in over here, and there you can see it on the screen. Okay, so we already tidied up a lot by having some constants here, but you'll see there's another thing we're copying and pasting. We keep writing the same text over and over. First, we write out something at a certain font size, and then we go forward. And you can see we've done that forward step size 3 times, and that right command 3 times, and that font size 3 times. So do you remember our friends called functions? I'm going to write a function called write and step. That's going to do all those things in one go so that I don't have to write as much code every time I want to spit something out onto the screen. So here goes. So at this point, I've created the function called write and step, but I'm not actually using it yet. I'm still using the write and move forward. So I'm going to replace each of these instances with write and step. You're going to notice I'm going to get rid of the font size here because we don't need to pass it in anymore. That is now contained inside our function. And also the forward step size is going to disappear because that's also inside our function. And when I run that program, you'll see nothing's changed, but man, is our program much shorter and neater. Okay, so we have our write and step function. We also have learned that we can write strings, numbers, and constants to the screen. It's going to get a little confusing. At the moment you can see there's the 42 and there's the 1, 2, 3, 4 to do with where we just spat out the number 42 over here. And then we spat out the constant 1, 2, 3, 4. Wouldn't it be nice to give a little description before each of those numbers are spat out to the screen? And this is going to be the first expression you learn. The first expression is going to be how to combine a piece of text or a string with a number. So where we were outputting our constant, I'm just going to say the constant is, in quotes, because that's a string, and I'm going to use the plus character. It's called the concatenate or the append character, and I'm going to add onto the end of the words constant is the actual constant itself. So when I run it, you'll see over here it says constant is, then there's that space that came after there, and then it's concatenated or appended our constant onto the end of that string. So you can see now it says constant is 1, 2, 3, 4. So cool. Now that we know how to write constants out to the screen, and we know how to put a little description in front of each of them, let's get down to doing some proper mathematics. Whenever we do the mathematics, and it's using something called an expression, we're going to store the answer of that maths into a new constant. And we do this so that we can give that new constant a name. If we give it a name, we're going to be able to use that constant in future mathematical expressions as well. Okay, so our first mathematical equation is going to be something pretty simple. Let's imagine we're buying some eggs. And let's assume there are always 6 eggs in a box. Now imagine, no matter how many times we buy a box of eggs, we always find 2 bad eggs in that box. We want to know how many good eggs are left over. So let's do a little program to help us work this out. So here we have a very simple little program. Our first thing we do is we create a new constant that stores 6 eggs per box. We then create a new constant called good eggs per box, but what we store into that is the previous constant minus 2. Remember I said we always seem to find 2 bad eggs in the box. So how many good eggs would be in a box? Well, it's going to be the number of eggs in a box minus the 2 bad eggs. And we store that in this new constant called good eggs per box. And I'm simply going to write and step that out to the screen. And what you'll find is we have 4 eggs. Now the cool thing is if we make 8 eggs per box and rerun this, you'll see the number of good eggs has now changed to 6. So our computer program is doing the mathematics based on the numbers we have stored in the constant before the program is run. Remember, constants can't change during the running of a computer program. You can only change them before you run the computer program. So now imagine I buy 10 boxes of eggs. How many good eggs are going to be in that crate of 10 boxes of eggs? Let's write ourselves another program. We're going to create a constant of boxes per crate. And let's say there are 10 boxes in a crate. So we will have good eggs per crate. And you use underscores to separate these words in a constant so it's easy to read. That's going to be equal to the number of boxes we have in a crate times the number of good eggs per box. And you'll see we use the little star or asterisk character. It's the one if you press Shift 8 on your keyboard. We use that for multiply. If I put the number of eggs per crate and run it, you'll see we expect to get 40 eggs in our crate because we have 10 boxes of eggs in a crate. If I change that to 120 boxes in a crate, you'll see it's worked out there should be 480 eggs. So you can see how fast our computer is doing our calculations for us. Okay, so we've done subtraction, we've done multiplication. I'm not going to show you how to do addition. Why don't you try that yourself? You're going to use the plus character. Now let's move on to division. And probably the best use of division in the world is to work out averages. So imagine you got exam scores for maths, science, and English of 84, 90, and 77. And your mum wants to know, well, what was your average score for the exams? We're going to write a little program to do that. Although our little text editor is a little narrow here, I'm going to move through it so you can see. Here we've created our constants, the score for our maths mark, our science mark, and our English mark. We're then creating a new constant called average. And what that's going to be is inside inside parentheses, and I'll tell you why just now. We're going to add the maths score to the science score to the English score. We're going to then close those brackets and we're going to divide it by 3. And then we're just going to spit out that score average. So our average score for our 3 subjects was 83.67 recurring. Later on, I'll teach you how to format these much more nicely. But for now, let's just go with it's 83.66666667. You'll notice we used that / command to do division. So we use the star for multiplication, the one above the 8, and the / for division. Notice that we had to put these brackets around our addition so that we can be sure that this expression, that our computer is going to do the adding together before it does the dividing. You may have heard of BODMAS, B-O-D-M-A-S, in mathematics class. It means brackets over division, multiplication, then addition, then subtraction. So that's the order that a computer, or that we do in mathematics, and a computer will do the same. The way it will evaluate, or the order in which it will do the multiplies, divides, adds, and subtracts is in the order brackets first, then division, multiplication, addition, subtraction. The short acronym to remember that is BODMAS. So by now we have created our own little calculator for finding the average of 3 scores. For homework, why don't you try and make it find the average of 4 or 5 scores? You're going to have to create some more constants. You're going to have to add more of them together. And don't forget, you're going to have to divide by the total number of scores you're adding together. But what's pretty cool about this calculator is if I go barely past English with 50% and I run the program again, you'll see my average has dropped from that 83 or whatever it was to 74. You can see how fast a computer is at doing these recalculations for you. Okay, seeing as we're in the maths world right now, let's try a few other formulae. Perhaps you already know the area of a circle, if you're given the radius, basically half the width of a circle, and you want to know the area of it, there's a special formula for that. You can skip this example if you don't yet know that part of maths, the area of a circle, but to work out that area, we need this mysterious little number in mathematics called pi, and we multiply that number by the radius of the circle, and that radius a second time. So you multiply pi times radius times radius. Let me do that now. So there you have it. A simple little program. If I change the radius, you'll see the area over here keeps shifting, so that if the radius of a circle is 5, or the diameter, which is twice the radius, is equal to 10, well then the area is going to be 78.5. But if that radius is only 3, and I run the program again, you'll see the area is much smaller at 28.27. So now you've added to your repertoire of calculators a quick way of working out the area of a circle, just given its radius. Try a few areas of yourself. And finally, to round it up, let's try one more. Perhaps while being on holiday in another country, you've wondered how to convert degrees Fahrenheit, like the temperature in degrees Fahrenheit, to the temperature in degrees centigrade. Well, here's the formula for you. So here we have a kind of crazy formula. You put the number of degrees Fahrenheit into this constant here, and then it does this formula here. It subtracts 32 from that Fahrenheit temperature. It then multiplies by 5 and divides by 9, and it stores that in temp Celsius. And remember, we've had to put brackets here around that subtraction, so it does the subtraction before it does that multiplication and division. You'll also notice when I called write in step, I started with temperature Fahrenheit. I then concatenated it using the plus command with the word Fahrenheit is, and remember to put spaces there, so there's a space between the number and the words. Then I put the temp Celsius, and then again I concatenated Celsius on the end. So I actually did several concatenations in a single write and step command, and that's how you end up with this very long sentence up here. Pretty cool. You can concatenate as long as you want. So now you have a calculator for converting Fahrenheit to Celsius. If it's 60 degrees Fahrenheit, I rerun the program, it tells me 60 Fahrenheit is 15.5555 Celsius. Nifty, right? You've built yourself today the ability to average a whole lot of scores together, to work out the area of a circle, and to quickly convert Fahrenheit to Celsius. And that's all in the space of 10 or 15 minutes. I wonder what you're going to do with the rest of your afternoon. So just remember, when we do maths, these long or short statements like that one, we call them mathematical expressions when doing programming. Expressions can be very short, like a constant minus a number, or they can be quite long, like this Fahrenheit one, where we've subtracted, multiplied, divided, done brackets, or where we've added a whole lot of things together, like the constant and then some string. Those are all called expressions. But a very important thing to remember is, no matter how long your expressions are, always try use constants with good names rather than putting magic numbers in those expressions. Just have a look at this one here. Why have we used minus 32? Why have we multiplied by 5, divided by 9? It would have been much better if there were good reasons for those. But at least we do know the first thing is the temperature Fahrenheit. If we just put the 60 in here, well, now there'd be 4 magic numbers, and you wouldn't really know which number to change if you wanted to change the temperature in Fahrenheit before working out Celsius. So always remember to use good names for your constants. Long expressions with magic constants or with magic numbers everywhere would be a great way for you to introduce bad bugs into your code, and you'll find you'll be pulling your hair out trying to work out why your code is not working. So use good constant names. Okay, so let's do a quick recap of our code. Right at the top, we had these first 3 lines. Clear the screen, move the dinosaur to the home position, and pull up the pen so that we can move him forward without drawing a line. That's fairly standard. That we'll be using in a lot of our programs, because we like to run the program from scratch over and over, and we want to clear the screen and start again. Next, we wrote our own function called write and step that would take in a value that we want to write to the screen, and it would write that out to the screen in a certain font size and move forward a certain number of centimeters. We can change those constants if we want it to be bigger writing or more space between the writing. And then finally, we have a whole lot of examples of creating new constants, writing them to the screen, and then creating expressions out of these constants and storing them in even newer constants and writing those out to the screen. And what we ended up with is 3 or 4 very useful little calculators for some useful concepts in real life. I'm going to leave this code in the description below this video so you can see it for yourself. You can copy and paste it into the text editor over there. So have a look down in the description below. And if you're up for the challenge, for homework, why don't you try find a few formulae of your own and try code them up in the text editor here and see what they spit out. Show your friends what you've come up with. And always remember, you can't break anything. So the best way to learn is to keep trying different examples. If ever you do end up breaking something and it's telling you there's an error or the browser's not working anymore, you can always hit refresh and restart. And so that, Codosaurs, is all the time we have for this episode. So on that note, this is Dr. J signing out. See you next time.